b to the power of 1 over n is the same thing, guys, as writing nth index of your b. So if this is your denominator, it becomes the index. And your index has to be bigger than 1. In your base, it appears here that has to be a positive number equal to 0 or bigger than 0. Okay, so like 1/4 is fine for the base, but look at the n. Okay, it said it has to be bigger than 1. So it can't be a half, but can be it can be a 1.5, it can be 1.01. So your denominators got to be bigger than 1, but your base, you can start with 0 and higher. So an example of that is going to be 8 to the power 1/3. The denominator is now the index, and then your radicand is 8 because that's your base, and we had to simplify. Cube root of 8 is 2. So your denominator, students, is the same as your index when you rewrite it as a radical expression. So another thing to look at would be this one right here, b to the power m over n. Okay, look at the base. Base is the same, but your denominator is your index, and the exponents is the same exponents here. Now, when you write it like this, it's the same thing as doing the square root or the cube root or the nth root first, and then raise to the power. So you can raise to the power first, or you can raise to the power last. And similar restriction for n and b. B's got to be at least 0 higher, and n must be bigger than 1. So an example down here would be 27 raised to the 2/3 power. Index is the same as your denominator. Your power is the numerator, and that's going to be the same as we write 27 and take the cube root of that, because remember, cube root of 27 is 3 times 3 times 3. And then raise to the second power. So that's going to be 3 times square. 3 times square. 3 square is going to be 9. So that's how we simplify that piece. So if we look at the right side, it says the numerator is the same as your exponent. Okay, so denominator is index, numerator is the same as your exponent. So let's go try some of this on your own. Okay, rewrite using radicals. Simplify if you can. So base is 64. Radical means we have to have a radical sign. Your denominator is going to be 3, so that's going to be index. Your exponent's 1, so it's kind of like writing 64 I meant, to the 1 power. Oh, that doesn't. 64 to the 1 power. But we really don't need to write 64 to the 1 power. Now 64 is 8 times 8. Okay, third index. And as you know, cube root of 8 times cube root of 8 is going to be 2 times 2, which is going to be 4, because it's a simplify if we can. So this is your equivalent radical. So we're going to box both up. So box that up and box this up. Okay. Number 2 says write as a radical. Denominator is 2, so that's going to be a square root, and then x to the 1 power, or just x to the 1 is fine. And we can't simplify square root of x, so we box it up. 1/8, guys, is your base, and then there's a negative. Okay, so negative power. So what that means is we're going to put 1 divided by 1/8 to the positive power 1/3. So make sure you guys listen to this really carefully, okay? And this is your index. So it's going to be 3 as your index, and 1/8 is on the inside. And that's going to give us 1 divided by cube root of 1 divided by cube root of 8, which is the same, guys, as 1 divided by 1 over, because cube root of 1 is 1, cube root of 8 is 2. This is the same as writing 1 divided by 1 over 2. When we multiply by its reciprocal, so it's going to be the same thing as 2 over 1, which is the same thing as 2. So we simplify and we box up as 2. Now, if we kind of see it, if you have this negative power, okay, keep in mind to write it as a positive power. Notice how we kind of move it to the bottom. That's just sort of how we write an equivalent expression if we have a negative power. All right, let's do this one right here. We write this as a radical. So that's going to be 7th index of x. And that's as far as we can go since we can't simplify that one. Okay. All right, so let's go see example. Oh, I missed example 3 altogether. Let's go back and do example 3. Sorry, guys, I didn't even see it. All right, so this one over here says 1 over negative power half there. So let's write it positive first. So it's going to do 1 over 49 to a power of half. Okay, so denominator is 2. So that will give us a square root of 49, which square root of 49 is 7. So when we simplify that down, that's just going to be 1 over 7. 81, similar process, 1 over 81 to a positive power of 1/4, negative exponents, rewrite it as positive because it's easier. Then that's going to be 1/4 index because your denominator is 4. 81, students, is going to be 4th index of 9 times 9. 9 times 9, which is 4th index of 3 times 3 times 3 times 3, which we can take out one of the 3's because it's a 4th index and we have 4 3's. So final answer is 1/3. So as you can see, this is the radical form of that, and the final answer of that is 2. And this is a radical form of that, and the final answer of that is 1/7 because we can't have radical on the bottom. This is a radical form, and the final answer is 1/3. So we can now, if we can't simplify it in radical form, we can rewrite it in rational exponents and then see if we can simplify that further. Okay. All right, example 8, similar process. Let's write, it's a positive exponent, so we don't need to rewrite it as in the bottom. So, but the index is going to be 3 because that's your denominator. You have 8 and the numerator is 2, so that's the same thing as 8 squared. Or if it's easier, then you can write it like this. Okay, these are exactly the same. It's up to you to use whichever one you want. So I'm going to use this one. Okay, so cube root 8 squared, it's 8 times 8, which is cube root of 8 times cube root of 8. As you can see, it's identical. Look at that. Then that means cube root 8 is 2 times 2, and that's going to give us 4. Okay. We have 8 and 9. I want to make sure I pinch it in so I don't forget. All right. This one, the index is going to be 3 because that's going to be your denominator. So that's 20, okay, with index of 3. Your numerator is 2, so you can write it inside or you can write it on the outside. That's really up to you. The bottom is 2, so I'm going to write it like that. Since I have the index is 3 and I have a 20, so that's going to be the same thing as 20 times 20, still over 2. Then I'm going to simplify some more. 20, guys, is going to be 10 times 2. And then another 20, so it's going to be 10 times 2. And as you can see, 10 is going to be 5 times 2. So keep on going. 5 times 2, and then times 2, and then this is another 10. So that's going to be 5 times 2 times 2, all over 2. So since your index is 3, I have 4 2's to be exact, but I can only take out a set of triplets. So I'm still going to have something left on the inside. I can take out 1 2, and cube root of 5 is left. 5 is left, and a 2. Okay, so 5 times 5 is 25 times 2 is 50, all over 2 on the outside. Reduce that, and our final answer is going to be cube root of 50, just like that. Okay, now what happens when you guys have the bases are the same and you guys are multiplying? Remember, let's roll up really quickly. When you multiply in algebra 2, we add the powers. Look at this, we add the exponents. So we do the same thing, and if the denominator is not the same, then you have to find the common denominator. Okay, so this one, the basis is going to be 27, so we will add the exponents only. 1/3 plus 4/3, so that's going to give us 27. 1 plus 4 is going to be 5 over 3. we have to see if we can rewrite that, students, as radical. Your index is the denominator, so that's 3. Your power, students, is going to be 5. So you can write it like this, okay? Cube root 27 and then to the 5th power, just like this. Well, cube root of 27, students, is going to be 3, okay? So that's 3 to the 5th. And 3 to the 5th is the same thing as saying 3 times 3 times 3 times 3 times 3, like that. So as you can see, this is 9 times 9 times 3. And as you can see, so I need to pull it up. 9 times 9 is 81 times 3. 81 times 3. Remember, 80 times 3 is 240. And 1 times 3 is 3. So 243 is our final answer. And you thought that was not possible. But look, first, we added the powers because the base is the same. We rewrote this rational exponent as in radical, and then we simplify all the way through.